with a square base and a top. Okay, so the base is a square, fine. So then I know that this is x, x, x everywhere. And the height is the height of the box. The cost per square foot for the bottom, the cost for the bottom per square foot is 15 cents. Okay. For the top is 10 cents per square foot. And for the sides, it's 2.5 cents. So for the sides, 2.5 cents per square foot. Okay. What dimensions will minimize the cost? Find X and H for a minimal cost. For a minimum cost for the box. Okay. So first we have to look at the surface area of the box. It has two identical top and bottom, but the base, the bottom is, the area is x squared. The sides are x times h, and the top is also x squared. But I'm more interested in the cost of the surface area. So if I want to write the surface area, let's write it, but I don't need it per se. I would have x squared for the base, plus another x squared for the top, plus 4 multiplied by x times h. So each side has base times height, but there are 4. The top has x squared. Why am I saying the numerator? I have no idea. So and the base of x squared. But we are interested in the cost. Total cost will be, for the base, I have the area multiplied by 0.15. So x squared times 0.15 plus. For the top, I have x squared times 0.10 plus. For the sides, I will have 4 times x times h times 0.025. So this is the area for the base. This is the area for the top, for the lid, and this is the area for the lateral area of the box. Now, I notice that I have a problem. Here's my problem. I can't have two variables. We will discuss functions of multiple variables later on in the semester, but not now. But I don't have a problem to get from here, from the volume. The volume of the box is area of the base times the height. Volume of the box, area of the base, multiplied by the height. And that is equal to 320. The area of the base is very clear. It's a square. So from here, I will solve for the height. 320 over x squared. And I forgot to number my pages. 7, I think I am 8, 9, and 10. Okay, so now I'm indeed going back to replace this by 320 over x squared. And only then I can say for sure this is a function of one variable. Right here, I should have not written it because I did not replace h. So I have 0.15. 0.15 x squared plus 0.10 x squared, I get 0.25 x squared, 0.25 x squared. And here I have plus 4 times 0.25, I get 0.1, right? So that's 100, right? So it's 0.1 times x times h, which is 320 over x squared. I will simplify one of the x's. I will multiply, and I have 0.25x squared plus 32 over x. Yes, in order to minimize, I have to find the derivative. After do I want to find the least common denominator yet? No, I want to differentiate without changing it into a fraction. So I'm not going to do that. It's much better not to. Okay. Good. So I'll differentiate now, and I get 0.5x minus 32 over x squared. I hope moving forward, because we need this later, you will remember that 1 over x prime is negative 1 over x squared. Very important to remember this. Now, this, I need to find the LCD. I have no choice. So c prime of x has x squared in the denominator. I have to multiply by this. So I have 0.5x cubed minus 32. And when I set this equal to 0, the numerator has to be 0. So 0.5x cubed minus 32 equals 0, or x cubed equals 320 over 5, which is 60. And now I have to take the cube root. And x equals the cube root, the cube root of 60. Do I know that this gives a minimum? No. I have no idea. Any questions? And I think I put here the wrong decimal, because I think it was just 2.5, right? It was 2. Oh no, I think it's okay. Everything is okay, right? So 2.5 cents. Yes. Yep. It appeared to be a little less expensive. It's 2 cents. Yep. Okay. So I need to show that this is the correct, that indeed gives a minimum. So x, the cube root of 60, and this is c prime of x, and this is 0. And when I plug in 0, I get negative. And when I plug in anything above, I get positive. So this is indeed a minimum. Okay. So this is x. I need to determine h. So when I determine h, I get 320 divided by the cube root of 360. And the measurement units are all in feet. Any questions? Any questions? Any questions for me? Is everything okay, everyone? Any questions? Do we want to look at other problems? Minimizing, maximizing different functions. Any questions? Anyone? So do we want to look at other problems?
Can we do one more?
Yes, please. Do you have any idea of, we looked at maximizing revenue. We looked at minimizing cost. The profit too. Maximizing area, profit, revenue. Marginals, profit, we looked at profit, surface area. Yeah, some of them are regular types of problems that I work on with my college algebra classes. You can seem to find something more interesting. Maximizing. Okay, let's look at maximizing volume. Okay, 52 on page 257. The Postal Service places a limit of 84 inches on the combined length and girth of distance around a package to be sent parcel post. Fine. What dimensions of a rectangular box with square cross section? So this is again a rectangular box. And here's the cross section. And that is a square, which means sides, the end are also rectangular box. Square cross section will contain the largest volume that can be mailed. On the combined length and girth all around a package to be sent parcel post. Okay, what dimensions of a rectangular box with square cross section, so this is X and X, of course, will contain the largest volume that can be mailed. So we want to maximize volume. And we are given this restriction. This, again, is the combined length. So I'm going to call the length Y. So 84 inches is Y plus 4X. One more time, it says there are two different girths, right? So also this could be the length. It says on combined length and girth of distance around a package to be sent parcel post. What dimensions of a rectangular box with square? This is an interesting problem, I think. I don't know if it interests you, but I think it's an interesting problem. Okay. And they're giving us a hint, and they say, in parentheses, if you're looking at the problem, it says there are two different girths. Okay. So also 84 must be the length, which is Y, plus the length all around, which is Y plus X plus Y plus X. So 2X plus 2Y. So these cannot exceed 84 inches, right? So length, this is clearly the length Y, plus the girth, which is the distance around, which is X, 4X. or 84 is the length plus the distance all around, which will be a y, an x, a y, and another x. Now, what about the volume? The volume of this box is the same thing like we just discussed, area of the base times the height. So there will be still yx squared multiplied by y. Okay, so when we combine like terms here, we have 84 equals 2x plus 3y. I will solve for y because I need to replace it in here. So I will move 2x to the other side. So 84 equals, I'm sorry, minus 2x equals 3y. So then y equals 84 minus 2x divided by 3. I will replace this in the volume formula. So then the volume, now it's a function of x only, with x squared multiplied by 84 minus 2x divided by 3. I will distribute and arrange in descending order, and I get negative 2x cubed plus 84x squared and divided by 3. I am asked to find the maximum volume, so I will find the derivative of this function. I will separate it first into two fractions, like negative 2/3 x cubed plus 84 divided by 3 is 26. Is that correct? 28? Yes. 24 to, yes, 28. 28 x squared. And now I will differentiate v prime. I bring down 3, so this is negative 2x squared plus, I think that this is 56x. And I set this equal to 0. No critical numbers coming from f prime being undefined, of course. So negative 2x squared plus 56x equals 0. I will divide both sides by negative 2. So I have, again, x squared minus 28x equals 0, and I will factor out x and get this. I cannot consider x equals 0. That's not, it's not possible. I will not have a box if x is 0. The other option is 28, and that's inches. So I have to study the sign of the derivative. So this is x, and 0 here, 28 here, and v prime. And this, when I study the sign and I plug in, let's say, 1 in between, when I plug in 1, it's going to be positive. And then when I plug in 50, it's going to be negative. Because this will be 2,500 times negative 2, negative 5,000, and this is less than negative 5,000. So it's going to be negative. So this is obviously giving a maximum. It's typical for the sequence of signs for the derivative. So if in case we need to, do they ask us to, they say, what dimensions of a rectangular box will contain the largest volume that can be mailed? Okay, so therefore, I have to go back and find y. So 84 minus 56. So y will be 84 minus 56 divided by 3. So what do I get at the top? I get, I think, is 28 divided by 3. Is it? So 5 from 7 is 2. 28 divided by 3 in inches. Any questions? Any questions? Okay, I would like to talk a little bit about